Welcome to the demonstration of the Kafka order processing system. This system is an excellent demonstration of a robust real-time data processing pipeline built on Apache Kafka, showcasing Avro schema enforcement, real-time data aggregation, and fault tolerance, retry logic, and DLQ. This system uses Apache Kafka for messaging, Avro for strong schema definition, and Python to implement critical business logic, including running average calculation and robust error handling using dead letter queue. Let's see how each component works. Before we go into deep of the project, I'm going to introduce system overview and the workflow. The system simulates an e-commerce web platform processing orders and can be broken into three main phases. First one is the producer, creates structured order data and serialized it to Avro binary format. Second one is the consumer. Consumer reads the binary data, performs real-time aggregation, and decides if the message proceeds successfully, needs a retry, or must to be sent to DLQ. Third one is the DLQ consumer. Monitors the dead letter queue for permanent failures that requires human review. Let's go into the project. Data definition and serialization. These files enforce the structure and format of the all data in pipeline, which is the key for reliability. Order AVSC file is here. This JSON file defines the immutable blueprint for an order record. Purpose of this file is it guarantees that every message in Kafka has the exact structure. This prevents the data type errors and ensures all consumers interpret the data uniformly, regardless of programming language. Second one is the Avro serializer. This file contains the core logic for converting data between Python dictionaries and the efficient Avro binary format. Serialize Avro function takes the Python dictionary and uses JSON load to pass the schema file, then uses fast Avro schemeless writer to convert the dictionary into compact byte array suitable for Kafka transport. Another one is the deserialize the Avro function. Reverse the process. It takes the Avro bytes from Kafka and reconstructs the original Python dictionary using fast Avro schemeless reader. Let's go to the producer Python file. This script is the entry point for the data into the system. It generates the simulated order record with a unique UUID and a random price and a random product in an infinite loop. It calls serialize Avro to convert the Python object to Avro bytes. It sends the Avro bytes to the orders Kafka topic. The delivery report callback confirms the message successfully reached the broker. Here, the create the order message, then the serialization part. Here is the exception try block is designed to catch fatal errors like malformed schema or missing value, which stops the producer from injecting bad data into the stream. Second one is the consumer Python file. It runs the localhost 9092 and the topic is orders and DLQ topic is orders DLQ. This script uses two variables, total price and count here for real-time aggregation, and it maintained in memory to calculate the running average price of all orders processed since the consumer started. This demonstrates basic real-time stream aggregation. Here is the DLK consumer file. When we go through the file, it is error logging and inspection. It handles the final stage of permanent errors. It subscribes only to the the orders DLQ topic. It is designed to simply log the contents of the permanently failed error messages. This term will act as audit trail, indicating which orders could not be proceed and require manual inspection or debugging. Deserialize the message using Abro schema and the log the permanently failed message. Here is the exception handling. Unlike the main consumer, the DLQ consumer does not reproduce the message. Its job is to record the final failure. Now we can run the project. Producer is running. Then we can run the consumer also. Also DLQ consumer. Producer is running like this. Consumer consumed order and the average price, running average price is also displayed like this. DLQ my consumer is DLQ order proceeds are displayed with the order ID, product and the price.